All right, for this section, we are going to be looking at interest rates and exponents. And we're going to be using a problem just called a lottery problem, which is you have a large sum that you can deposit in a bank account and gain interest on. So we're going to use $50,000 and 5% interest. So you look at this, you won the lottery, small lottery, but you put the money in and you just sit there and let it grow. How much is it going to be worth year after year after year? So this is not like the pay it forward problem, because in this problem, it's going to be going up by just 5% each time, a little bit each time, compared to the pay it forward or the bacteria problem we did last time, where it's doubling or tripling or quadrupling. This is just going to be going up by a little bit. So if you take a look, if we start with $50,000, and I would suggest pausing the video if you don't have a calculator right now, and make sure you have a calculator with you. So if we have $50,000 and we're looking at a 5% interest, we can multiply that by the 0.05. And that $50,000 at 5% interest is going to gain us $2,500 in that first year. And then we can take that $2,500 and add it back to the $50,000 in the bank that we didn't touch, and you're going to have the $52,500, which is the account balance over here. Another way to do this problem that I'm going to show you is take that $50,000 and multiply it by 1.05. We're going to talk about this in a little bit, but that's 5% more than the 50,000. That's 5% more. And if you look at this, you can now do this in one term, 52,500. And then again, you can do the 52,500 at the end of the first year. Multiply that by 1.05. And you get the 55,125. And then again, if you take that, multiply by 1.05, you get this. So what you should notice is that we're constantly multiplying by 1.05, which is our next now rule. So how do we know that this is growing exponentially? We can look down here. How do we know this is growing exponentially? Because multiply the next equals now times 1.05. So what number are we multiplying each year? I kind of repetitive, but this is 1.05 to get the next account balance. And here's where the function rule comes in. The way this function rule works is your interest, your total interest. Typically, this is going to be used by the letter I. Is going to be your principal, your rate, and your time. So this is pretty much how it works, where this is your interest rate, this is how long you want to do this for, this is your principal that you started with, and this is your total that you finish with. So you can use an I or a T. I'll use here, just to change this up again to something different, we'll use a letter T. So the total amount is the P and then 1 plus R to the T. So if we want to use this to, let's say, this fourth year, this 2020, what we can do is we can say, well, what happens if we have, and we'll go over to calculator, 50,000 times, and then we're going to do this as 1 plus 0.05. And then the exponent key is right here below the clear symbol. On any handheld calculator, still this little caret up arrow to the power of, let's say, 4 years. And you notice here we have 60,775. So 60 and 31 cents. So basically what we're looking at is, we want to find our total. We're going to do the $50,000 we start with. 1 plus, and then my interest rate is 0.05, and then to the T. And I'm going to leave this T up there because you can pick and choose whatever time you like. So this is really the formula for the problem. And then we can use that to solve. So what is it in 2025? Let's say 9 years later. So we can go up here, and we can just edit this to 9 years instead of 4. Hit enter, and in 9 years it's going to be $77,000. Where will it be in, say, 24 years? You can look at this. So in 24 years, it's 161,000, a lot of money. And then if you want to look at 54 years, you're talking 696,000. So it's almost kind of like, here's where you start, and let's say you're a teenager, you retire, you're going to have, $600,000 when you're done in 50 years. When will it first become $100,000? This is where you can kind of do a little guess and check. 9 years is 77,000, 24 years is 161,000. So let's just try to do a quick guess and check here. And let's guess, say 12 years. Didn't work, just a little under. Try 15 years, right around there. Try 14 years, right there. So somewhere between 14 and 15 years is going to go over $100,000. So hopefully it makes sense how to use this little interest rate formula here to create an equation like this for any of these problems. Good luck.